Hello students, welcome to Educate. Today we are going to start next chapter of class 12 physics. So let's start. So here we have already studied about basics of electromagnetic waves, like speed of electromagnetic waves is given by c equal to 3 into 10 to the power 8 meter per second, and its precise value is 2.99792 into 10 power 8 meter per second. But we generally take this value for the ease of calculation. Now we are going to see the basics of light. So you have already studied about reflection. This is incident ray, this is reflected ray, this is normal, this is angle of incidence, this is angle of reflection. They will be equal. Then what you have seen, in case of mirror, we use certain sign convention, and that sign convention is called Cartesian sign convention, in which mirror is placed at the origin. Distances towards right will be positive, distances toward left will be negative. If we measure height upward, it will be positive, and if we measure height downward, it will be negative, and direction of incident light will be like this, right? So this is very basic. Now you also know about the focus. These are the parallel rays. They are meeting at certain point on principal axis. This point will be called focus. Similarly, in case of this is convex mirror, in which it seems that light rays are coming from this point. So this is focus for that, and then we define focal plane. Focal plane comes into play when incident light makes certain angle with principal axis. So here this is focal plane. You can read the definition here. It's given if the parallel para-axial beam of light were incident making some angle with the principal axis, the reflected rays would converge or appear to diverge from a point in the plane through f normal to the principal axis. This is called the focal plane of the mirror. So this is very basic thing. Then comes one important relation. You have to derive the relation. F is equal to R by 2. So for this purpose, we consider a mirror, and here this is parallel ray to the principal axis, and it will pass through focus. This is focus, and if we draw normal, so it will pass through center of curvature. So this is C. If this angle is theta, this angle will also be theta. This is reflected ray, right? So here this angle will be 2 theta. This angle will also be theta, right? It's obvious from diagram. Now here we draw perpendicular from this point. Say this is D, and this point is P. We will assume that this portion, this curvature of the mirror is small, means we say that aperture is small. In that case, D and P will be assumed to be very close, right? So distances measured from D will be assumed to be measured from P. So here, if we take tan theta, so tan theta means here tan theta is perpendicular divided by base. So tan perpendicular is, say this point is M. So MD divided by base is DC, right? Similarly, if you take this triangle MFD, so tan 2 theta is equal to perpendicular MD divided by DF. And if theta is small, in that case tan theta will become theta and tan 2 theta will become 2 theta. So we can write theta equal to MD divided by DC, and 2 theta is equal to MD divided by DF. and then we put the value of theta here. So we will get twice of MD divided by DC is equal to MD divided by DF. Right? Up to here there is no problem. MD will cancel out, and DC can be taken as PC. Right? So twice, two times MD will cancel out. So just we write PC. Right? In place of DC we write PC, and divide by this will become 1 upon DF. DF means we can write PF. So if we use sign convention, so PC will be minus 2F, or PC is radius of curvature. So PC can be written as either minus R or minus 2F. So here we write 2 divided by minus R equal to, this will become 1 upon minus F. We can cross multiply. So F into 2 equal to R, or F equal to R by 2. So this is required result. I think you have understood. Now one more important result we are going to derive, that is mirror formula that you have studied at lower level. Here what we have to take, here we will draw perpendicular from M to this point, and then we will consider. So let's draw the diagram here so that thing may become clear. So this is mirror, this is pole, and we will assume that aperture is small. This is parallel ray to the principal axis, and it will pass through focus, right? And one ray, suppose object is here, so object is A and B, so one ray will pass through center of curvature. This is center of curvature, so image will be formed here. This ray will go like this, then it will come back. So image A dash and B dash will be formed over here, right? And this point we assume that, say it is M, this is P, this is mirror, we can polish it. Now here this distance, this is perpendicular drawn on the axis, say this is D, right? Now what we can do, our purpose is to get 1 upon F equal to 1 upon V plus 1 upon U, right? So we can consider similar triangles. So we consider this triangle and this triangle. Let's make it clear for you. It is like this. This is A dash, this is B dash, this is A, this is B. This angle is 90 degree, this angle is 90 degree. This point is C, right? So these two angles will be vertically opposite. These two angles are 90 degree each. So triangles are similar. If they are similar, then ratio of their sides will be proportional. So we can write AB divided by A dash B dash, right? And then basis AC divided by A dash C. Further, we can do some changes. AC we can write starting from point P. So we can write PA minus PC. PA minus PC. It is PA minus PC, right? Divided by A dash C. A dash C means PC minus PA dash. PC minus PA dash, right? So up to here there is no problem. Now we consider this triangle, this MD, and this is F. So let's draw this diagram also. Here this is A dash, B dash, this is F, and this point is M, and this point is D, right? So here again these two angles are vertically opposite. This angle is 90 degree, this angle is 90 degree, and AB equal to DM. Why? Distance between parallel lines remain constant. So this is MD, or MD is same as, so MD is same as AB. So again we consider this ratio. So let's write MD or AB. So we write is AB divided by perpendicular of first divided perpendicular of second, a dash b dash equal to base of first. Base of first is fd divided by base of second will be a dash f. Now FD, we can do certain approximation, as I told you that when aperture is small, then D and F will coincide. In that case, FD can be written as PF. So let's write it as PF and divided by A dash F. So A dash F can be written as PA dash minus PF. PA dash minus PF. Right. And then we can equate the two because LHS is same, AB upon A dash B dash, AB upon A dash B dash. So when we equate, what do we get? So PF divided by PA dash minus PF. PA dash minus PF. Now we can put the values. PF means focal length. Focal length will be negative here. Minus F divided by PA dash. PA dash means distance of image. So minus V minus PF will be plus F, right? Equal to PA. PA means distance of object. That will be minus U minus PC. PC means it is 2F, or radius of curvature, right? Divided by PC, so minus 2F. Here PA is minus U, in between there is minus sign, and we are taking PC, so it will be negative, so this will become positive, right? And then 2F PC minus PA dash. PA dash means it is distance of image, so minus, so this will become plus V, right? Now let's do cross multiplication. So this will give 2F square minus VF is equal to UV minus UF minus 2FV plus 2F square, right? So 2F square will cancel out, and then we can do one thing. All negative terms we can shift to LHS. So this is minus VF plus 2VF, right? And then this plus UF equal to UV, correct? So what do we get? So we will get VF plus UF equal to UV. Now we can divide it by UVF. If we divide by UVF, this will become 1 upon U plus 1 upon V equal to 1 upon F. So this is a required relation. So I think you have understood. Now next portion is magnification. Magnification means here we can consider these two triangles, this like this ABP, and this triangle like A dash B dash P. So ratio of perpendiculars, and here we are considering triangle like this. This is P, this is B, this is A. This triangle, and this is 90 degree, and there is another triangle here. These two angles will be same because here this angle theta, this angle will be theta. So another figure we are considering here. So let's draw it here and say this is A dash, this is B dash, right? So these two triangles are similar because this angle is 90 degree, this angle is 90 degree, this angle is theta, this angle is theta. So ratio of perpendiculars and bases will be same. So this is H, say it is H1, this is H2. So first let's write AB divided by A dash B dash, right? This is ratio of perpendiculars. divided by ratio of bases. So this point is P. So PB divided by PA dash. Right? Here we can write like AB. That will be better to avoid confusion. This is A. This is B. So in place of PB, we should write here PA. Correct? Up to here, there is no doubt. Now, AB is positive because it is a bird. So we write here H1, but A dash B dash is negative. So minus H2. And PA is distance of object from pole. So that will be minus U. And PA dash is distance of image from pole, that is minus V. So what have we got from here? We have got, if you write it, V upon U equal to minus H2 upon H1. It's clear. This will cancel out. Or if we want to find out H2, or we can write H2 upon H1 equal to minus V upon U. So this is required formula that we will make use. Right? Now, here there is one question. Let's see. This is an important question. Suppose that the lower half of the concave mirror's reflecting surface, in figure, you can consider any figure in which, suppose we are talking about this figure. Suppose we consider like this. So if lower half, this portion is made black, they are saying that this is covered. Suppose that the lower half of the concave mirror's reflecting surface is covered with an opaque, non-reflective material. What effect will this have on the image of an object placed in front of the mirror? So what will happen? Intensity of light will be reduced, number one. So you may think that the image will not now show only half of the object. This will never happen. But taking the laws of reflection to be true for all points of the remaining part of the mirror, here also there will be reflection. So image will be formed. It's not necessary that this portion is covered, then image will not be formed. The image will be that of the whole object, right? However, as the area of reflecting surface has been reduced, the intensity of the image will also be reduced, right? So this is important point. Here there is one question that if this is a mobile, then we have to show its image formation. So it's obvious what will happen. If we consider this object, so we have to take two values of U. One of this point till here, from here, and another of this point. Then for V, this portion will remain intact because it is at C. So object placed at C will form its image at the same point. So this is same. But this image of this point will be formed over here. So that thing is drawn here, straight line. One ray, this is passing through focus, and like this, and another way goes like this, and that will become parallel to principal axis. So this is how image is justified. Here, what is the question? A mobile phone lies along the principal axis of a concave mirror as shown in the figure. Show by suitable diagram the formation of its image. Explain why the magnification is not uniform. Of course, it will be not uniform. Here, it will be magnified because image of this portion will be formed here. Distance is increased, right? But here, for this, image is formed at the same point. That is why equal in size. So, will the distortion of image depend on the location of the phone with respect to the mirror? Of course, it's obvious from here. So, this is given, you have understood. Now, next question is, an object is placed at 10 centimeter, 5 centimeter in front of concave mirror of radius of curvature 15 centimeter. Find the position, nature and magnification of the image in each case. So you remember very well how to evaluate. So here values are given. You have formula 1 upon V plus 1 upon U equal to 1 upon F. But keep in mind, If you are considering a concave mirror, then F will be negative, U will be negative, V depends. So here in this question, object is placed at 10 centimeter. It means U will be negative, minus 10. First case we are considering. And focal length, radius of curvature is given 15 centimeter. So focal length will be just a half, but it will be negative. So minus 7.5. Then we apply formula 1 upon V plus 1 upon U equal to 1 upon F, and we evaluate. It comes out to be minus 30 centimeter. Means image will be to the left of the mirror. And then we can find magnification. We know the formula for magnification, M equal to minus V upon U. We can put the values. V, we have got this, make it negative, that will become positive. And then U is 10 centimeter with negative sign, so we will get minus 3. Minus 3 means, what is rule? If M is positive, then it will be virtual and erect, right? And if M is negative, it means real and inverted, right? One more thing, modulus M means without sign if we check. So three possibilities are there. M can have any three value. Either M is greater than 1. M is greater than 1. M is greater than 1 means enlarged. M is equal to 1, it means equal in size. M is less than 1, it means diminished. So these are the conditions. So here, as per rule, we will get minus 3. Minus 3 means if we ignore the sign, we will get 3. 3 is magnified. M is greater than 1. So it is magnified, enlarged. Negative sign shows that image is real and inverted. Now, we consider second case when object is at 5 centimeter. In that case, image will be virtual. Of course, what is happening here? The situation will be like this. We can see it through diagram, that if object is lying somewhere here, then what happens? This focus. So one ray will go like this, and then it will pass through focus. Right? This is focus. So this ray will go like this. Another ray will pass through C. In this case, it will diverge. So it will pass through C, it will go like this, and they seem to be converging at a point on other side of the mirror. Right? So this is the case that we are going to deal with. In second case, so here we are given U equal to minus 5 centimeter. So we can take U equal to minus 5 centimeter, and F we have already got minus 7.5 centimeter. We put these values, so we will get V equal to 15 centimeter. Then we find magnification. This time it is positive. So what do we conclude? That image is magnified, virtual and erect. Correct? So you have understood it fully. Now there is very interesting question. This question you must know. This is sometimes asked. Suppose while sitting in a parked car, you notice a jogger approaching towards you in the side view mirror of R equal to 2 meter. If the jogger is running at a speed of 5 meter per second, how fast the image of the jogger appears to move when the jogger is 39 meter, 29 meter, 19 meter, 9 meter. All cases are same. You can calculate any one, you will understand. But what is the concept behind here? In this, if object is running means you have to consider two situations. Initially, here, suppose object is at this point. So U will be 39 meter in first case, right? Corresponding to this value of U, you have to find out what is V. When you take 39 meter and you evaluate, you will get value of V. Then since object is running, in 1 second what will be new position? So since 5 meter per second speed is there, so after 1 second it will cover 5 meter. So initially it was 39, Now it will reach 5 meter closer. So its situation will be 34 meter. So next time you have to take, suppose we write here U1, corresponding value V1. Next time you have to write U2, right? Then you have to reduce this distance by 5 meter because object has covered 5 meter. So this will become 34 meter, although you will keep U negative, that you know. Corresponding to this, you have to find out value of V, that is say V2. Now, here our concern is to find the speed of the image. So very simple. Speed of object can be found from here. 39 minus 34 divided by 1. Similarly, speed of image can be found from here. We have got two values of V, and then find the difference. Time is 1 second, so that will be the speed. So the same thing is done here for all parts. This is a very simple concept. So here first they have evaluated U equal to minus 35 meter, then V is this much. This is first case. And now, as I told you that after 1 second U will be reduced by 5 meter, so it comes out to be minus 34 meter. Now corresponding to this distance, corresponding to this value of U, we can find V, and then we can find the difference. So here same thing is given. These are the values of V corresponding to two values of U. When 39 meter, when 34 meter, then these are the values. Then we get this 1 upon 280 meter. So we can say that average speed of the image when jogger is between 39 to 34 is 1 by 280 meter per second. I think you have understood. Now second case, object has reached at 35 centimeter. So you will take again U as 35, and then you will consider U 5 meter more, so you will reach at 29. You can evaluate like this. So different situations are there. It is very simple. You can easily calculate. Now we are going to see another phenomena, that is refraction of light. You know, when a light ray enters from one medium to another, what happens? It deviates from its path. Now, if medium is denser, optically denser, I mean, in that case, what happens? In that case, the ray will move closer to the normal, and if medium is optically rarer, then it will move away from the normal, right? Then here one pertinent point is Snell's law. If you remember, sine I divided by sine R is equal to refractive index, which can be written as either N or mu. It is very obvious. Suppose we consider two medium. Suppose this is air and this is say water, and here this is say angle of incidence, this is incident ray, so this is I, and this is denser, so the ray will move like this angle is R. So if we write sine I divided by sine R, then we will get a refractive index of water with respect to air. So we can write mu, either we just write mu or we can write the notation that ray enters from air into water, A mu W, right? Here some important relations we can draw, like principle of reversibility. Suppose we are given the same thing, means A, we have seen A mu W is suppose 4 by 3, means refractive index of water with respect to air is say 4 by 3, and suppose you want to find out refractive index of air with respect to water, so it will be 3 by 4. Why? What is rule? Rule says A mu W multiplied by W mu A is 1, right? This is true for any two media, like suppose refractive index of glass with respect to water is, with respect to air is 3 by 2, then refractive index of glass with respect to here Just reverse. This is refractive index of glass with respect to air, and now refractive index of air with respect to glass will be 2 by 3. So this can be found by using principle of reversibility. Now suppose there are three media. So let's consider the case. Suppose here there is air and light ray enters like this. This angle is I, and this say this is water. Then what happens? It will bend, right? And suppose this angle is R1, and here we again draw normal, so this angle will also be R1. Then another medium, we can draw little wider diagram, so later on we will draw, and this is say glass. So further there will be contraction and ray will be like this, and then here say this will be R1, this is say R2, right? And then the final angle will be again I. If it is not clear, so let's draw it clearly so that thing will become very clear. Here we are considering, suppose this is normal. This is one ray, right? We can make this angle little wider. Suppose this is normal. This angle is like this. Sorry. This angle will be like this, and then there is problem in drawing, don't worry. Okay, this is normal, this is angle of incidence I, right? And this is air, and this is say water. And now when this ray enters in water, so it will get little deviated, and it reaches at this interface. Say this angle is R1, right? We are taking R1. So here we can write a refractive index at this point. It will be, we can say, A mu W will be equal to, this is air to water. So sine I upon sine R1. No problem. Now when we reach at this point, we draw normal here, and this angle will be same. This is R1, right? Here say this becomes R2. It is not straight, it is little bent. So this is say glass. So at this interface, what will be the formula? Water to glass. So we write W mu G equal to sine R1 divided by sine R2. Then we reach at this point, and again we draw diagram. Here this angle will be R2, and here again ray will be parallel because it is going in air, so it will be same angle as I. So at this point, glass to air interface, we write glass to air will be equal to sine R2 divided by sine I. Now, if we multiply all three, what do we get? A mu W times W mu G times G W A equal to sine I upon sine R1, then sine R1 upon sine R2, sine R2 upon sine I. So what do we get? Everything will get cancelled and we will be left with 1. So our final relation will be A mu W multiplied by W mu Z multiplied by G mu A equal to 1. And as far as principle of reversibility is concerned, that also we can see, like suppose this is incident ray, this angle is I, and now this is going like this angle is R, and here we place a mirror. Then what would happen? The ray was coming like this. Now it will reverse its path. So first we write formula. Suppose this is air and this is a glass. So first case, if we write A mu G, so that will be equal to sine I upon sine R. And if we write just reverse case, means when ray moves like this, in that case we will write G mu A will be sine R divided by sine I. Now if we multiply the two, we will get A mu G multiplied by G mu A, that will give 1. So this is called principle of reversibility. So by using this concept, we can easily find the refractive index of one medium with respect to other. As far as the terms optically denser and optically rarer are concerned, so when we talk about optically denser medium, what does this mean? It means speed of light reduces, right? If that medium has a refractive index, suppose medium has a refractive index, say mu, the speed of light in that medium will be c upon mu, or we can say mu equal to speed of light in vacuum divided by speed of light in that medium. So this is another formula. So we have got two formula for refractive index. One is c upon v is mu, this is the first one. Another is mu is sine I divided by sine R. Let's take some basic questions based on it. Suppose we are given V equal to say 2 into 10 to the power 8 meter per second. This is speed of light in any medium, and we have to find out what is refractive index of that medium. So we can apply formula C upon V equal to mu, and we can use the known value of C, that is equal to 3 into 10 to the power 8 divided by V is equal to 2 into 10 to the power 8. This gives 1.5, right? And another concept, if suppose angle of incidence I is given, suppose I is given say 45 degree and R is given say 30 degree, and we have to find out refractive index mu. So formula is mu is equal to sine I divided by sine R. So sine 45 degree divided by sine 30 degree. We put the values 1 upon root 2 whole divided by 1 upon 2. So this will become 2 upon root 2 or root 2. Correct? So I think you have understood up to here. There is no doubt. Here, the concept of lateral shift is shown. Do you understand what is lateral shift? So lateral shift is simple, means this is angle of incidence, this normal. So actual path, if there is no deviation, it would be like this. But since this medium is denser, let's make it little bigger so that thing may become clearer. So here situation is very clear. This is glass slab in which this is normal, this is angle of incidence. So if there is no deviation, the ray would go like this. But sorry, but there is deviation. So actual path will be like this. And now at this point again, this will go like this. This will become parallel to incident ray. So this shift is called lateral shift. This can be calculated mathematically, but now it's not given in your syllabus, so I'm not going to explain. For competition purpose, you have to study the relation. Now there is another concept in which if object is kept in a denser medium and we observe it from rarer medium, then the depth seems to be little less, and such depth is called apparent depth. And how this apparent depth is related with the actual depth, that we can calculate. But before that, let's see what is happening. Object is lying over here. I think it is clear. So object is lying over here, and this is one ray which is going directly perpendicular. This is another ray which is deviating here because this medium is rarer. Another ray is like this, it is going like this. So it seems that these rays are meeting at this point. So instead of appearing at this point, object is appearing at this point. So there is a normal shift. Shift means there is shifting up position of object from original position to this apparent position. So OO dash will be called as normal shift, and this depth, this from here, from surface to this point, this will be called apparent depth. Now, how they are related? So it is very simple. We can say actual depth divided by apparent depth is equal to refractive index, is mu. So actual depth, suppose we write d, and apparent depth, say we take t. So we can say d equal to mu times t, or t equal to, it is d upon mu, right? So this is apparent depth. Now suppose we want to calculate normal shift. So normal shift means, when we talk about normal shift means actual depth minus apparent depth. So actual depth is d minus apparent depth is t. So d minus d upon mu. So d you can take out, 1 minus 1 upon mu. So this is how we can calculate. We can take examples like, suppose you are given actual depth, say d is given as, say d equal to, say 20 centimeter, and refractive index is given as, say 1.5, and apparent depth t is to be found. So you know formula very well, that t is given by d upon mu. So d is 20 divided by mu is 1.5, or we can write 20 into 10 divided by 15. Then we can cancel. So 3 times 2 times. This will be 40 upon 3 centimeters. Correct? And here, if you want to find out what is normal shift, so subtract the two. Normal shift, say x, that will be 20 minus 40 upon 3, that is 60 minus 40 divided by 3, which is 20 upon 3 centimeters. So you have understood up to here very well, I think. Now, next point is total internal reflection. What is this concept? What is total internal reflection? So we can think about it like this. You know that whenever a light ray, suppose this is denser medium, right? This is a rarer medium. So what happens? So suppose this is normal, and light ray is incident at this point. This angle is, say I1. Then it will move away from normal. Suppose this angle becomes this. Take another case. Here we are going to increase the angle of incidence. So in this case, suppose this is I2. We have taken I2 is greater than I1. So suppose this increases and the situation becomes such that this angle becomes this. This is incident ray. Refracted ray becomes parallel to this surface interface, right? So this angle becomes 90 degree. So this angle of incidence is called critical angle. So here critical angle, right? So we can say, if we write I2 as C, and this is I2, and this is R, angle R becomes 90 degree, and suppose the refractive index of this medium is mu, and this is air whose refractive index is 1. So what relation do we get? So ray is moving like this, right? So we write sine I2, sine I2, sorry, sine I2 divided by sine 90, sine of 90 degree equal to refractive index of this medium with respect to this. So it will be equal to how much? I will tell you another formula so that you can easily get. Here you will get sine C equal to 1 upon mu. But before that, I would like to tell you one more thing, so that will make things easier. You can easily find. So there is one rule that we can follow. Suppose this medium has a refractive index mu1, this medium has a refractive index mu2, and as I told you, this angle is say C, and here we have got this angle as 90 degree, right? I'm taking same case but differently. So here there is one formula, mu1 sine C is equal to mu2 sine R, where R is 90 degree. So mu1 sine C equal to mu2 sine 90 degree, right? Mu1 is mu and mu2 is 1. So here we write mu sine C equal to mu2 is 1, and this is also 1. So from here what do we get? Sine C equal to 1 upon mu, right? So this is a necessary condition that critical angle, sine of critical angle equal to 1 upon refractive index of the denser medium. We can take one numerical example to clarify this. Suppose you are given C equal to, suppose C equal to, it's say 60 degree, and we have to find out what is refractive index. So formula says sine C equal to 1 upon mu, or mu equal to 1 upon sine C. So this will become 1 upon sine 60 degree, which is sine 60 is root 3 by 2, so 2 upon root 3. I think you have understood. And a reverse case, suppose the refractive index is given, and suppose mu is given, and you have to find out, suppose mu is say 4 by 3, and you have to find out what is critical angle for it. So you know very well sine C equal to 1 upon mu, or C equal to sine inverse 1 upon mu. You can put the value sine inverse, and then this will become 3 by 4. Now you can use the table, and you can get, either you use calculator. Here one simple trick for Pythagorean triplet, I can tell you that if you are given, this is say 3, this is 4, so this will be 5, right? So corresponding to this, so here angles can be written as like this will become 53, and this will become 37 degree, right? So if we find sine theta, this is 37 degree, and this is 53 degree, corresponding to 4, this is bigger angle, corresponding to this is smaller angle, so that you can remember. This is easy for 37 and 53 only, this is valid. So what will happen here if we evaluate sine C? So sine C will be how much? Sine C will be equal perpendicular upon hypotenuse, so 3 by 5. But this case is different, because we are not getting that thing, right? So C will be sine inverse 3 by 5, and sine inverse 3 by 5. So here sine theta will be 37 degree. So corresponding to that you can evaluate. But here this value is little different, so you can keep it till here unless you have calculator to find exact value. right? This concept you will make use somewhere, wherever you will come across such. We have also used this in rotation. There was one question in which such situation was given, but at this moment you don't have to use. You should leave at as sine inverse and then put the value inside, or if you get tan inverse, so just put tan inverse and value inside, unless it is given in question itself. I think you have understood. Other things related to this phenomena we will study in next lecture. Thank you for watching. Team Educate